In this video, we're going to talk about a mercury bulb thermostat. You don't see these old mercury thermostats much anymore. This one is built with a base, a sub-base, and a cover. The base and sub-base are what you see when the cover's popped off. You can see the exposed terminals for connecting the low-voltage wires, the mercury bulb, and the anticipator. The cover's job just makes it look neat and protects the parts and gives you a place to adjust the externally displayed temperature. In a simple system, you might have just 3 wires. Red, or R, is your 24-volt power coming from the transformer. White, or W, calls for heat when the mercury in the bulb tips and closes the circuit for heating. Yellow, or Y, typically calls for cooling on many systems, though not every system even had cooling. Many of you may be familiar with systems up north that only had heating. Inside, you'll notice a small glass tube with a tiny bead of mercury. When the temperature changes, a bimetal coil tilts that tube. Let's talk a little bit about a bimetal coil. Picture 2 different metals with slightly different rates of expansion bonded together. As the temperature in the room changes, those metals don't expand or contract at the same speed. That slight difference causes the coil to curl or uncurl just a bit. This coil is carefully calibrated so that as the temperature dips below your set point, it twists in a way that tips the mercury bulb. The tiny bead of mercury inside the glass vial rolls to one end, closing the electrical circuit on the W terminal and signaling the furnace to turn on. When the room warms up and the coil bends back in the opposite direction, the mercury rolls back, breaking the circuit and telling the furnace to shut off. It does the exact opposite in cooling mode. This all works because mercury is both a liquid and it conducts electricity. But remember, mercury is hazardous. Old thermostats like these shouldn't just be tossed in the trash. They must be recycled properly so that mercury doesn't end up in our environment or contacting human skin. If you're replacing one, be sure to recycle it. You can find a recycling location or mail-in program at thermostat-recycle.org. Now let's talk about the heat anticipator. The anticipator is a tiny heating element built into the thermostat's control circuit. Its job is to slightly warm the thermostat sensing element, making it shut off the heat a bit before the room overshoots the set point. By doing this, it keeps the system from running too long, helping the room settle right at the chosen temperature without constant swings. In modern thermostats, this is done through the thermostat programming. But remember, these older thermostats had no integrated circuit board, so the heat anticipator is an analog way of preventing temperature overshooting. Setting the anticipator is about matching it to the current draw of your heating control circuit, or the white circuit. You can find this printed on the furnace board, or you can measure it with an amp clamp over the white wire. In cases where this current is lower, you may need to use a signal amplifier. When the current's very low, your meter may not read accurately. You can use a 10 wrap of wire wired in series with the white circuit in order to measure this more accurately. Simply take the measurement and then divide by 10 in order to find what the true current is. Once set, that's it. The thermostat keeps things comfortable using a gentle bit of trickery from the heat anticipator. Also remember that old mercury thermostats required the thermostat to be completely level in order to work properly, and often required some calibration. While mercury bulb thermostats may not be very common anymore, understanding the basics of how they work is an important part of HVAC history and gives you some insight into some basic electrical circuits and thermostatic control. Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.